Welcome. My name is Chuck Ridgway. I'm the Advanced Technology Manager here at Horner. And today we hope we've got a very informative live stream for you. Today we're continuing on, which we started last week, or we're continuing on what we started last week when it comes to Cscape 9.9 Service Pack 4. So this week we are talking about IEC. So this is part 2 of our two-part series. And joining me today, Mr. Casey Gardner. How you doing, Casey?
Hey, not too bad. How's it going, Chuck?
It's doing great. So there are a lot of new features with Cscape 9.9 Service Pack 4, and a lot of new IEC features as well. Which ones are you looking forward to?
They packed quite a bit into Service Pack 4, but I think the one I'm probably looking forward to most to definitely get my hands on is the simulation capability. Because especially as an applications engineer, it's really nice to be able to do some of those debugging and simulating enhancements just without even the necessarily need of a controller on hand a lot of the times too. So I'm definitely looking forward to that one for sure.
Absolutely. And just to reiterate to the folks who've just heard Casey's comments there, the simulation initially is available for the Enhanced IEC, and then over time we're going to add that into the other languages at Horner as well. Okay, thanks for your thoughts, Casey. Casey will be monitoring the chat and answering any questions he can answer during the program. And then if there's anything I missed or anything I got wrong, which happens from time to time, he'll be back on with me here at the end, and we'll wrap things up. Okay, let's go ahead and get started. So just to quickly review, Cscape 9.9 Service Pack 4 has been out for about a week now. It's now available from our website. The companion firmware for that is version 15.5. And as always, make sure you read the release notes. See what new features are there that you can take advantage of, maybe what bugs have been fixed that are important to you, or not, as the case may be. And then, of course, always make a informed decision when you decide to upgrade. And, of course, always do plenty of testing before you deploy a machine into the field. We're going to give you that disclaimer every time, just because we want to make sure that you get the most out of our new software and firmware without any negatives there. So, last week, we talked about registration, licensing, converting register-based programs to variable-based programs. This week, it's all about IEC, and there's 4 pretty new categories, if you will, or more than 4 probably, but we're going to cover 4 different areas. We're going to provide you an overview of Service Pack 4 when it comes to IEC, or Enhanced IEC specifically. We're going to talk about online programming. We're going to talk about simulation, that feature that Casey mentioned a minute ago. And then we're also going to give you some early information about advanced debugging, although I'm not going to demonstrate that particular feature this week. We want to spend more time on it in a future session. So let's dive into part 2. First, let's do a little review on Cscape logic programming in general. Okay, so Cscape is a free programming package that we offer here at Horner. It's a package that we design, that we program. We have complete control over it in terms of adding features, fixing bugs, those sorts of things. And Cscape is used for configuring all aspects of the Horner OCS all-in-one controllers. And Horner OCS all-in-one controllers basically are hardware devices which have the capability of a PLC with a built-in HMI, with onboard I/O and networking capabilities. And again, Cscape is the free programming environment for the Horner OCS. Now, when it comes to logic programming, what the intellectual property that tells the machine how to operate, that you program, or that our customers and our OEMs program into the OCS using Cscape, you have multiple options when it comes to logic. First, when Cscape was first invented back in the late 90s, it supported one language, and that was Advanced Ladder. So that's kind of an American-style ladder logic. And originally, that ladder logic was strictly register-based. So you had to manually assign every variable to a specific memory location. And then a few years later, we added the ability to make it variable-based, where you don't have to map every single variable over to a specific memory location in the controller. Now, whether you're talking register-based or variable-based, again, American-style ladder logic or advanced ladder as we call it, does not necessarily follow the PLC open specification to the letter. Okay, but it's very effective and it is still our most popular language that people use. Now, that being said, IEC 61131 languages have been very popular for some time, and we've been supporting them from some time. So as an alternative to just strictly using advanced ladder, you can choose instead to use IEC languages. And those, from a Horner standpoint, follow much more closely the IEC standards and the PLC open specifications. Okay, so, we didn't kind of go off and do some interesting, unique things from an Americanization standpoint. We decided we should probably follow the specification pretty closely. And in doing so, we've added support for multiple simultaneous languages, like all manufacturers do that support IEC 61131. So you have your choice between ladder logic, structured text, function block diagram, sequential function chart, instruction list. All of those, you can use all of those languages, some of those languages on any particular project. And again, we've been supporting IEC for some time now. All modern Horner controllers support all of these options for logic. So when you start a new program, a new project, you have your choice of what logic you want to use. Do you want to go with advanced ladder? Do you want to go with one of the IEC options? Now, it doesn't matter, frankly, what version of logic you choose. All other aspects of OCS configuration are virtually identical. So when you configure your graphic screens or your networking or you configure your built-in I/O, it really doesn't matter what logic you're using. It's going to be the same for all those other aspects of the controller. Okay, so what is new then with Cscape 9.9 Service Pack 4? Well, what's new is what we call Enhanced IEC Logic Programming. Again, we've supported IEC languages for some time, and we have quite a few users who have been using it for some time and enjoying it, but they've been asking us for some enhancements, and we have performed a major upgrade and a major update to support a lot of the things they've asked for. Now, first of all, it's not available in all controllers. We really added some things to it that require a little more horsepower, a little higher end hardware. So therefore, not every controller we sell has the ability to support the enhanced version of IEC. So it's not supported, for instance, in the XLE and XLT. It's not supported in the Micro OCS series. However, it is supported from the X5 on up, including the RCC and including our most popular series, the XL series, which consists of, as you can see here, all of our controllers from the XL4 on up and including our XL Plus 15-inch. Okay, so all those controllers support the enhanced version of IEC. So what do we mean when we say the enhanced version of IEC? And of course, I'm going to go into quite a few details, not only with kind of slides and graphics, but also we're going to do some live demonstrations as well. So the bottom line is Enhanced IEC is significantly more feature-rich. Okay, so there are new data types supported, additional instructions supported, better system event handling support. We'll talk about that in more detail. All of these, of course, in more detail. And some advanced functionality, including the simulation, Casey mentioned, that you're going to like. The capacity is significantly different. So when you use standard IEC languages with any Horner controller, you have the ability to use up to 10,000 variables. And that's a lot, no question. But with the enhanced IEC, you can take that to a totally different level with up to 64,000 variables. Also, the execution is significantly faster. We've got a brand new logic execution engine that is running in firmware, starting with 15.5. Remember, that's the companion version of firmware that goes along with Cscape 9.9 Service Pack 4. So when you load that firmware into, let's say, an XL4 or an XL7, you're actually adding a new logic execution engine for IEC that removes a few bottlenecks and just offers tremendous increase in performance versus what we have offered to date with standard IEC. Another thing to keep in mind is when you move to enhanced IEC, there is no longer any translation whatsoever when it comes to internal memory types. So, of course, we still have external memory types, things like analog inputs and outputs, digital inputs and outputs, because let's face it, when you are configuring or programming your logic, you need to be able to create variables and reference specific I/O pins on the built-in I/O, for instance. So you're still going to have to map over to real-world I/O points. And also, we also have system memory, which is still relevant, system bits, system registers, those sorts of things. However, when you're talking to general-purpose word variables, general-purpose bit variables, whether they're retentive or non-retentive, those really have no relevance anymore with Enhanced IEC. So therefore, the execution time, because there's no translation in between, the execution time is one of the things that has been positively impacted. So does that mean our standard IEC that we've been supporting for many years now, like you may be already using, does that mean that you've got to switch or that it's going away? Absolutely not. So if you are a existing IEC user and you want to continue on with using IEC the way you always have and not necessarily taking advantage of some of the updates, then that is your prerogative for sure. We're not forcing anybody to do the update. And we're also not taking away IEC capability from the XLE or XLT or the micro OCS series or anything like that. So want to make sure we nip that in the bud for sure. Okay, so now what we're going to do is I'm going to start going through some of the new features in the Enhanced IEC, some of which are kind of a big deal, some of which are just kind of nifty and nice and good to know and good to have. So we're going to kind of go through them one by one here. And there are other things that I'm not going to cover in this particular live stream. Don't worry, we'll cover those in future events when we can dedicate a little more time to them. So let's start with something called bit fields. Okay, so this is a new data type. You know, when we say data type, we're talking about things like integers, double integers, Boolean, that sort of thing. So we have a new data type called a bit field. So what is a bit field? Effectively, a bit field allows readable names to be assigned to a selection of bits within an integer. So I think a lot of you are familiar with the fact that with the OCS, we have traditionally 16-bit variables, and that at least from the standpoint of advanced ladder, you can address individually, you know, R1.1, R1.2. So you have the ability to access those individual bits within an integer, for instance. And that's a capability we've had at Horner for some time. So new in Enhanced IEC is a new data type called bit field. So if you have an integer which is made up of a series of bits and each bit has a specific meaning, then you now can create a new data type, a new bit field data type, that specifically outlines what each bit within that overall integer does. And it can be quite handy. And I'm going to go ahead and demonstrate that for you now. Examples of where you might use this would include things like some of the status registers for various functions in an OCS controller. You assign a integer type variable or multiple integer type variables, and sometimes there are individual bits within that integer that has a specific meaning. So you now have the ability in Enhanced IEC to use bit fields to kind of make that easier, if you will. Another example, which is the one I'm going to show, is the attributes for a graphical object, for instance. You assign an integer, but there are individual bits within that integer that you would manipulate to, you know, do things like flashing and those sorts of things, making things visible and invisible. All right, so let's go ahead and dive into that. I'm going to go ahead and switch over to Cscape, and let's take a look here. Okay, so what I've got here is I have a XL4, and I'll go ahead and just show you quickly kind of what we're talking about here. So just a simple XL4, which I often like to use for demonstrating here on Tuesdays. And there's really not much of a program in it. I've just got a simple screen here with a clock object. And going back to Cscape, the first thing I want to show you before I dive into the bit fields is I want to show you how to make sure that your OCS is licensed for Enhanced IEC. One thing I kind of glossed over there, not intentionally, I just kind of got rolling on other topics, was that Enhanced IEC is a licensed feature. And we talked about some other licensed features last week, things like WebMI and MQTT, etc. So Enhanced IEC is a licensed feature. It's something that you would license on a per controller basis. It has a list price of $50 US. And just like with MQTT, for the next several months, we are offering free vouchers or a free global license number that you can use to license every controller you've got in your possession to support Enhanced IEC. So feel free to do that over this period. So there's a global voucher code available for you to use to license all of your controllers for not only Enhanced IEC, but for MQTT as well. So what I have here is I have a IEC program, and let's take a look at how we, first of all, enable IEC in Cscape, because some of you may have never used it. And then let's also talk about how we can be sure that our controller, specific controller we're talking to, is licensed. I'm going to go to the Tools Application Settings area here and make sure that Support IEC Editor Programs is checked. So that means that when you do New Program, for instance, when you go to the File menu and say New Program, one of the choices for the logic languages that you'll have will now become IEC. So those of you who aren't IEC users probably didn't realize that you have to check this checkbox to have that option. And then with Service Pack 4, there is another checkbox available, and that is Enhanced IEC Default. So that's what I've got checked here. So that means is when I open a new program, I should say, when I create a new program, it automatically, when I select IEC, it automatically enables the Enhanced IEC capability. So that's the first thing we have to do, okay? Then the second thing we have to do is, before we actually load and run anything permanently on the machine, is we need to make sure that our controller is licensed. So let's go back to the Tools menu. This time, we're going to go to Editor Options, and under Compiler Options, we can make sure the Enhanced IEC mode is checked, which it should be if we have made it default. If we didn't make it default, we would need to manually check it here. And then we can hit Display Validate License. And if you remember the demonstrations we did last week for MQTT and WebMI, there's always a Display Validate License button available when you're in that particular feature. So I'll hit it here. And what happens is Cscape goes out and it checks to see if your controller, based on its MAC address, is licensed for this particular feature. And if you're not, you have the ability to do that. So as you can see here from this status, I am permanently licensed. Here's the MAC ID of the OCS I'm talking to, which is my XL4. And if I wasn't licensed yet, I would have the ability to hit the Obtain License button and then paste in the global voucher code. And I happen to have a copy of the global voucher code right here on my desktop. And again, that's available from our tech support folks, and I believe it's also available on our website. Until probably at least the end of July, this global voucher code can be used to license any number of controllers in your possession. And then after July 31st, to license additional controllers that you haven't already licensed, you'll have to purchase a voucher for $50 per controller. So that's how we enable IEC, Enhanced IEC, and how we make sure that our controller is licensed. All right, I wanted to get that out of the way first. All right, now let's go back and talk about bit fields. And to remind you again what I mean by bit fields, we're talking about the ability to assign specific functions to individual bits within an integer, okay, which can be useful for status registers as well as useful for things like global attributes or attributes on a graphical object. Okay, let's go ahead and dive in. So first thing I need to do is I need to create a new bit field. Where do I find information on bit fields? Well, I go to the Tools menu and I select Bit Field window. And it will pop up here in the corner. I like to kind of move it over where I have more room. Okay. And oops, did I hit enumeration instead of bit fields? No. Okay. So I had been the same window is shared for both enumerations as well as bit fields. So there's actually two tabs. So I had previously, before I had started the live stream, I had both of these open. So let's go ahead and start with bit fields. So I'm going to insert a new bit field. All right. And I need to give it a name. Bit field 1 is not very descriptive. I'm going to go ahead and give it a more descriptive name. And what I want to do in this case is I want to effectively create a bit field which I can use to manage graphic attributes for any graphical object that I might put on the screen in Cscape. Any graphical object that I may want to control the visibility of, any graphical object I may want to make flash, any of those sorts of things. Okay, so I've created this bit field called graphic attributes. Now the first thing you'll notice is that it creates a list of individual bits within that integer that we're talking about here. And one thing to be careful of is that with advanced ladder, everything is 1 based. Okay, with IEC, everything is 0 based. So we're talking bits 0 through 15 when we're talking about IEC languages. So I happen to know that bit 0 is the visibility attribute. So I'm going to go ahead and create, or I define that this individual bit here is visibility. Oops, visibility. Not sure if I'm spelling it right, but let's give it a go. All right. And the next bit I happen to know is the flashing. All right, so I'm going to go ahead and call this flash. Now, there are actually more than just 2 bits defined for this particular integer, but for now, for demonstration purposes, I'm just going to show you how to define the first 2. You could define the rest of them very easily in the same manner. The other ones are for things like changing color on the fly, those sorts of things. So we've created a bit field, graphic underscore attribute, and we've defined what its individual bits are doing, at least the lower 2. All right, so now let's go ahead and actually use this. So the next step is we need to create a new variable, okay, which we're going to use to put on the screen. And where are we going to put it? Well, we're going to go ahead and add a couple of push buttons to my XL4 here so we can just demonstrate how we can make it flash or make it invisible, whatever the case may be in terms of the actual time object there. So how we do that? How are we going to do that? All right, so we're going to create a new variable. I'm going to right click here under global variables, hit add variable. I'm going to call it the time display, okay, because we're going to use it to, we're going to manipulate this to effectively change the way we display the time. It's not Boolean type that we want. No, we want it to be graphical attributes type. So I'm going to scroll down through this long list here, down into alphabetical land, and there we have graphical attributes. Okay, so we've selected that. So we've got a new variable created called time display of the type graphical attributes. All right, so now let's go ahead and go to our screen. All right, and I'm going to drop, or first thing I'm going to do is I'm going to go in here to this time object, and under attributes, under display properties, you'll notice that we have the ability, if we want, to make any data field visible or invisible on the fly, flash or not flash on the fly, and we have the ability to change colors and other things as well. But to do this, we have to assign a variable. And so what variable are we going to assign? Well, the one that we just created called time display. Okay. All right, so let's go ahead and select time display and hit OK. All right, so we've done that. Now, if we manipulate the lower bit of time display, we're going to be able to control its visibility. And if we manipulate the second bit, we can control its ability to flash. So to do that for demonstration purposes, let's go ahead and just put a couple push buttons on the screen here real fast. We'll make them toggle switches. Okay, so let's go ahead and change from momentary to toggle. Let's go ahead under legend. We'll call this one visibility. All right. And the variable that we want for that we're going to assign to that push button is going to be our time display dot visibility. That's the one we're interested in. So that's how this bit field comes into play now. We can specify not only the integer, but also down to the bit level, and that can all be named. All right, and then I can do the same thing here. I'll just copy it, paste it, and we'll do the same thing for flash. Not the sexiest screen in the world here. I'll change this variable from visibility down to time display and flash. Okay, we'll change the legend to say flash instead of visibility. All right, And again, as you can see, we can define not just at the integer level, but also down at the bit level. All right, let's go ahead and download this to the controller. All right, we're doing that here. I'll go ahead and switch over to the XL4 view as we download here. Okay, so if you can see here, our time display is gone. It's invisible at this stage, but if I toggle the visibility attribute, it appears and disappears as I toggle it, and then same thing with the flash. Okay, so that's a demonstration of what we would call the bit field data type. Hopefully you'll find that useful. I think that's one of the new things that'll be definitely useful for sure. Let's head back to the presentation and let's take a look at what else we've added here in Cscape, because obviously there's a lot more to Enhanced Ladder than just adding bit fields. Let's talk about the enumeration type now. Okay, so again, it's a new data type. We just talked about bit field. Now we'll talk about enumerations. How do we access this? Well, what an enumeration does is it basically allows variables to be tied to a set of predefined constants. So one good way of thinking about this is a selector switch, right? Where you're selecting between hand, off, and auto, automatic, manual, whatever the case may be. You want to tie specific terms to specific data values. All right, so that's how enumeration can be useful. So let's just quickly show you how to do that in Cscape. I won't demonstrate this particular one by downloading it to the controller, at least not initially, but let's take a look at that and see how we would implement that. All right, so we're back in Cscape again. We go back to the Tools menu. All right, and this time we select Enumeration window. All right, make sure the Enumeration tab is selected here, and we're going to create a new enumeration. All right, and again, we want to give it a more meaningful name. In this case, let's call it machine mode. Let's say we're going to go ahead and replicate the functionality of a handoff auto switch on the touchscreen, and we want to create an enumeration type, and we're going to call it machine mode. Okay, and we do that. Now we have to define the different values that we want tied to machine mode, and they're put in order between 0, 1, 2, etc. So in this case, if we want 0 to be off, we would type off in first. If we want 1 to be hand, 2 to be auto, we could do it that way. And we've got a little checkbox here that we can hit. Okay, so that's all there is to it. We've now created an enumeration data type called machine mode. I probably should stretch it out here so we can see it. We would go into our variables again, all right, and create a new variable. Hit the add variable button here. Give it a meaningful name. In this case, let's call it HOA switch. That's pretty meaningful. Again, it's not a Boolean type. We want to pick it from the list, and we need to go down alphabetically and find machine mode on the list here. There it is. And we're good to go. So now when we go to the screen, all right, if we're going to go ahead and put a 3-position selector switch on the screen. Let me get this stuff out of the way here a little bit. All right, now we can tie that particular selector switch to that particular variable that we just created with that new enumerated data type. Okay, so I want a vertical selector switch, 3 positions. Item 1, I want to be off. Item 2, I want to be hand. Item 3, I want to be auto. All right. And I still haven't tied it to a specific variable yet. Let's do that now. All right. And there's my HOA switch variable. And we're good to go. Now, as I switch between handoff and auto, the value of that variable, HOA switch variable, is going to vary between 0, 1, and 2. And we have enumerated those 3 values, and we can use those elsewhere in our program. We can use those for in structured text. There's a lot of good uses for an enumerated data type for sure. let's go ahead and go back to our slides and take a look at the next thing we've added here. Okay, so bit fields, enumerated data types as well. Okay, now let's talk about some new instructions that have been added. A lot of instructions in relation to string handling. Okay, and we're not going to go through these individually. That would just take too much time. But we've summarized them here on 2 pages. So a few weeks ago, I actually gave a demonstration on doing interfacing with like RS-232 serial type devices that just spit out raw ASCII type characters with the OCS. And I think I used at that time, advanced ladder with tags, or advanced ladder that's variable based, as my language. I also could do that exact same application using the Enhanced IEC, and I would have a whole host of additional instructions available to me for handling ASCII characters, whether that's converting back and forth between integers and strings, whether that's dealing with looking up the ASCII code for a character, concatenating strings if that's what I want to do, extracting characters from a string from the left side, the right side, somewhere in the middle, whatever the case may be. So Enhanced IEC has added a tremendous number of string-based instructions that you'll be able to use for any application where, again, you need to manipulate strings. And it may not just be for dealing with things like barcodes and those sort of ASCII type scenarios. We also could be talking about doing some customized data handling, writing data to CSV files or something like that. So there are certainly other applications where you need to do string manipulation beyond just talking about barcodes and things like that. So plenty of new instructions in the category of string handling. All right, now let's talk about some new features or new capabilities, and that's handling system event better. So what does that mean? With Cscape, there are things that, with any controller, it's not just an OCS or Cscape, with any controller, you often want to deal with things in a certain way whenever you get faults, or maybe when the machine starts up or when the machine shuts down. Okay, so what we've added in Enhanced IEC is we have added the ability for users to have more control by providing a structured text routine that they can program every time the system starts up, every time the system shuts down. And then if one of a couple different errors occurs, if there's a divide by zero error, in other words, you've configured some math in your machine and you're doing some calculations and you forgot to handle the divide by zero properly, and you've done all the testing, everything looks good, but you forgot about this case where you could potentially get a zero in the denominator, and now you've got a divide by zero error and the machine's not operating the way you want. So that's a possibility. It could happen. Well, by adding a little bit of code to the routine that handles anytime there is a divide by zero error, you can tell the machine or the logic what you want to have happen in that scenario in case it does happen. If you're not doing any math, then you're not going to have a divide by zero error, for instance. Another very common error is a bad index on an array. So, in IEC as well as advanced ladder, we use a lot of arrays, right? We array variables, we change the index on an array, and it's possible if we have a problem in our logic that we could have a index on an array that's negative or that's bigger than the total size of the array, and it could cause all kinds of issues. It could be overriding other variables. It can be doing all kinds of bad stuff. So again, with Enhanced IEC, you have the ability to put some logic inside of a structured text routine that basically controls what happens when it detects a bad index on an array. All right, so that's a pretty valuable thing. And we'll go into that in more detail at some point in the future to kind of show you some examples of some of the code you could put in there that would cause things to react the way you want. But for now, we're just kind of letting you know that those new features exist. Okay, now let's talk about something such that a lot of us are familiar with, and that is Modbus, right? Modbus is kind of the de facto standard, lowest common denominator, simplest, most widely supported way of connecting devices from multiple manufacturers that's out there. Whether you're talking about a variable frequency drive or a PLC or any other types of device that you'll find on the factory floor, chances are it probably supports Modbus. And we don't always want to use Modbus. There's better networks out there, but it's certainly something that's widely used, and we talk about it a lot here at Horner because we interface a lot with third-party devices that support it. If you remember from one of my earliest slides on this Enhanced IEC, one of the real changes that were made, the fundamental changes, one fundamental change is that there really isn't any such thing anymore, with Enhanced IEC at least, of general purpose R registers, general purpose M and T bits. Okay, they don't exist as far as Enhanced IEC is concerned. Now, those are some of the memory references that play the biggest roles when it comes to Modbus. Because the way all other Horner controllers work, the ones that aren't running Enhanced IEC, there's a fixed memory map. So R1 is always, holding register 43,001. M1 is always, whatever output bit is assigned to M1 or mapped over to M1. So those are always a fixed memory map. If those memory addresses don't exist, then how do we handle that? Well, it's actually pretty simple, and it's something that a lot of people have really asked for, and that is you have the ability to create your own arrays for each of the 4 major Modbus data types: holding registers, which are read-write words; input registers, which are typically read-only words; output coils, which are read-write bits; and input bits, which are read-only bits. Those are the 4 major data types. So you can effectively just create an array for each of those and then assign that as the data that will be responded to whenever a Modbus message comes in. Remember, we're talking about Modbus as a server, Modbus as a slave. Okay? So you assign those arrays, just the ones that you want to be made available to the outside world over Modbus, and now that data is there and ready to go. As long as you remember to move over, using move commands and other things, the actual machine data that it needs to be reported. If you've got a machine and you want to report temperature and pressure, etc., you not only need to create the arrays to report the Modbus data back, but you need to remember to copy over the temperature data and the pressure data into that array so that it'll get reported properly. So let me just quickly show you how to configure that from an Ethernet standpoint. So let's jump back over into Cscape and let's go to the hardware configuration. So here's hardware configuration. I'm going to go into the Ethernet section. All right, and again, we are talking about Modbus TCP or Modbus over Ethernet as a server or slave. So this is where we enable Modbus server or Modbus slave over Ethernet with an OCS here in the LAN 1 config for an XL4. When I hit configure selected protocol, okay, you'll see something new. With all the other languages, you strictly select UDP or TCP, the port number, and decide if you want to create a write inhibit variable or not. That's it. Well, with Enhanced IEC, we give you the opportunity here to plug in these arrays that you're going to create for holding registers, input registers, etc. Okay? So that's really the approach that you take. So let me go ahead and I canceled out of that. I'm going to cancel out of that again. And I'm going to go in and actually create those arrays. Okay? So I'm going to go here under retained variables. And for the sake of this demonstration, I'm just going to add all these arrays to the retained area. So I'm going to go ahead and select or create a new variable called holding. Let's give it a little better name. Let's call it Modbus holding. My typing is a little shaky today. Holding registers. Okay, that is not Boolean but integer. And if I want to support, let's say, the first 100 Modbus holding registers, my machine that I'm programming, remember, it's not just a general purpose OCS. This is probably a machine that's doing something. And I may only have 5 or 6 pieces of data, holding register wise, that I want to report over Modbus. So I might make this array size 5 or something. Okay, let's just go ahead and do that. Instead of making it 100, let's make it 5. So let's say that there are truly just about 5 words of data that we want to report for this machine. Temperature and pressure and maybe maybe some, runtime hours or something like that. Okay, so I've created a new arrayed variable called Modbus holding registers. I would do the same thing for input registers. Again, those are integers. I would do the same thing for output coils. Those are read-write bits. I would do the same thing for input bits. Those are read-only bits. And I would set whatever size made sense for my machine. Okay, and then once I was done creating those variables, I would go back in here to my LAN 1 configuration under Modbus slave, and I would plug in the variable for that particular Modbus register area that I want to support. So I'm going to go ahead and plug in my holding registers here. All right, and for this scenario, I'm going to go ahead and plug in Modbus holding registers 0. Say OK, and OK. Okay, so now when a Modbus client or Modbus master requests holding register 40,001, whatever the value is of that first Modbus holding register sub-0, that's what's going to get reported. So if that's going to be my machine temperature, I got to make sure in my logic to copy machine temperature over to that first element of the array. So hopefully that gives you an idea of how that works. If you're talking slave, then that is just done with ladder logic using a Modbus slave map function instead of doing it from the hardware configuration. So I've kind of drawn that on the screen here. You can kind of see, again, if you're using Enhanced IEC, you can kind of see that we've got a Modbus map function block that you would use in ladder or the similar or the corresponding function for structured text, for instance, where you would configure, what is the source for the holding registers, what's the source for the input registers, etc. And, in addition to assigning things like the Modbus ID and, the Modbus timeout. Okay, so again, a fundamental difference in the way Modbus is handled because there are no more R's, M's, and T's. Effectively, you can create your own custom map for all intents and purposes. Let's go ahead and continue on. Okay, so now let's get to Casey's favorite feature here with simulation. And this is, again, like Casey mentioned, this is very functional. This gives you the ability when you're using Enhanced IEC to test out your logic even if you don't have hardware with you. Okay, that can be pretty valuable, of course. And it's accessible from the debug menu is where you can find that. So let's go ahead and demonstrate how that works. So again, back to Cscape. And let's see, how do we want to start here? Okay, let's start this way. I'm going to move this variable table kind of out of the way here. All right, so what I have here, again, a really dirt simple application just used for demonstration purposes. I just have a single structured text routine here that all that it's doing is it's got a variable called myvar or myvar, depending on how you want to pronounce it. Let's say myvar, which is just counting continuously from 1 to 100. So that's all that's happening with this particular structured text routine. If I want to make sure that's working properly, I could use simulation to make sure it's working properly. All right, so let me go ahead and go to the debug menu and click on Start Simulation. All right, so I'm clicking Start Simulation. And now you can take a look and see, if you look closely there, you can see, sure enough, my values are incrementing as I want. All right, so really, this is, of course, a really simple application. I hope I could write 4 lines of code to increment a variable. That's not all that complicated. But as control engineers, we do some things that are pretty complicated. So again, having the ability without a controller to be able to just go ahead and simulate that is pretty valuable. So again, just a really quick demonstration of the simulation capability. And then when you're done simulating, okay, you can go back to the debug menu and stop your simulation. Now, there's all kinds of other features here that we're going to spend a lot of time on in a future live stream. Things like single stepping, things like setting breakpoints and trace points, displaying a call stack for calling subroutines and user-defined function blocks. Those are great, great features for debugging and troubleshooting, but they deserve their own amount of time. So we're going to cover those in a future session. So I'm going to go ahead and stop the simulator here. So again, that's just kind of a little tease of the simulation feature, but you can see even in a simple application, it can be pretty valuable. The next thing we want to talk about is online programming. So online programming, effectively, is the ability to make a logic change, sometimes called an online change, without taking the controller out of run mode. Okay, so that's what online programming is. And PLCs, many PLCs have supported online programming for years. The OCS Advanced Ladder and Advanced Ladder with tags in our products like the XL series, starting with the XL4 on up, and including the RCCs and the X5. Those products also support online programming only if you're using Advanced Ladder or Advanced Ladder with tags or Advanced Ladder that's variable based. It's not supported in standard IEC. It is now supported in Enhanced IEC. Okay, so that is a new capability in Enhanced IEC, and we're going to show you how it works here in a minute. But we'll talk about how it works first, okay? So the first step, the reason we need to cover this is because it works a little differently than the way that it works in Advanced Ladder. And that's because the way that variables are allocated or mapped is completely different in Advanced IEC than it is in Ladder. Okay, so that's why it's relevant. So the first thing we have to do is we have to set up online programming first. And the first step of that is to activate it, and then also to allocate additional memory space where additional variables and other elements can be added when you make an online change. Because when you make the online change, you might be adding a variable, not just changing one. You could be adding a variable. You could be doing something else, and the controller needs to make sure that it's allocated memory for that so that when you make that online change later, it's prepared for it and it can handle it. Okay, so that's the first step, is activate online change mode, allocate the appropriate amount of memory for additional resources that are needed, and then download that in regular mode, not online change mode. Download that in regular mode to the controller so that it's ready when you do go into online change mode later. So when a unit comes out of the factory, you're going to have to at least download to it once in regular mode to set everything up properly before you're going to be able to go into online change mode. So just keep that in mind. And then once you've set everything up properly, then it's a matter of executing an online programming change, which effectively means make the change you want to make, go into debug mode. With Enhanced IEC, you accessed online programming from debug mode. So you enter debug mode, and then you do your normal download. And when you do your normal download, that kind of triggers the whole sequence of the online change mode. And let's just go ahead and demonstrate that here. Back to Cscape. So let's go ahead and download, well, let's do two things. One, let's download this logic into my XL4, and this is a standard download. Okay, so this is not a online change at this stage. So I'm just doing a traditional download, and effectively what happens here is my XL4 has gone into stop mode while it's taking the changes. Once it gets the changes, it'll go back into run mode. Okay, so this is a traditional download. Okay, so I'm going to have you on camera now. There we go. Now I'm sure I can hear you. Okay, so the first question was related to how many enums and bit fields can we handle. We don't know the answer to that one. We'll follow up on that one. The second question is
simulation for the whole program or just the routine you're looking at the time?
No, it will simulate the entire program. Obviously, what's up on the screen, you'll be able to see real time what's happening with the updated data. If you're not looking at a part of the code that is being simulated, you won't see its status, but you will it'll still be simulated. So that's a great question. All right, those are the two questions we had?
Yep, I think that's it for now.
Excellent, fantastic, and I'll figure out why I couldn't hear you before. So, all right, back to Cscape and talking about online programming. Okay, so what I just completed was just a regular standard old download. Okay, so the controller stopped when I did that. Now let's go ahead and go into the area where we set up online programming. And to do that, we're going to go here under let's see, I believe it's under debug. Hold on a second here. Tools, there we go. It's under tools. Tools, enhanced IEC project setting. Okay, so from this area in Cscape, this is where you have the ability to configure online change mode, and it's currently inactive. Okay, let's go ahead and double click on it here. Let's go ahead and hit activate. Now, when we hit activate, you just noticed a whole variety of items just showed up on this table below here. And what Cscape is encouraging us to do at this stage is to allocate additional space, additional resources inside the controller's memory for additional variables, additional other things that might be needed, so that if we make a future online change, the controller will be able to handle it because it's got enough space allocated for new variables, et cetera, okay? So what I like to do is highlight all of these categories. Okay, so I clicked on the first one, holding in Shift and clicking on the bottom one, so they're all highlighted. And I'm going to go ahead and hit Margin and hit 100 and hit Apply. What am I doing here? Okay, well, effectively, I just allocated resources of double what I'm currently using. So I've got 100% margin now on all the different areas which might be needed for expansion if I do a future online programming change. Okay, so that's the easiest way to do that. I've applied that, I've activated it, okay? So at this stage, we're good to go. All right, so I'm gonna go ahead and close out here. You'll see online change is now active. Okay, so now how do I do an online change? Well, the first step is I need to actually make the change that I want to make. So let's say, for the sake of argument, that what I want to do is I want to actually change to incrementing by 2 instead of incrementing by 1. Okay, so I'm going to go ahead and do that now. So I'll make it increment by 2 instead of 1. All right, I'm going to go into debug mode. All right, as soon as I go into debug mode, Cscape is taking the change I just made along with the other code, downloading it into a extra area in the controller memory. Okay, and now it's asking me if I want to implement the changes or not. Okay, and if I do, I would hit the do online change, and then the new changes would take effect. So the controller has not gone out of run mode yet at this stage. It's been in run the entire time. Even when we downloaded this change, it stayed in run mode. Now, for it to take advantage or actually to switch to this change, I have to hit this button here. And I'll go ahead and do that. All right. And it's going to communicate with the OCS, effectively make the change, and then it should come back, I believe, and tell me that the change worked or not. Oh, and look, the change failed. Okay, let's try it again. Oh, I know why it failed. It's often better to give you demonstrations of how not to do it than how to do it, right? Okay, so I believe I never did a regular download after I reallocated the additional resources that Cscape needed to properly do an online change. So I think that's where I screwed up. I should have done a regular download first before I attempted to do a download change. So we might work on Cscape a little bit in the future to give me a little better diagnostics there, but I'm sure that's what I messed up. Okay, so I'm going to go ahead and get out of debug mode just to be safe. All right, so that'll just take me back into regular editing mode. I'm going to go ahead and go back under, I think it was under Tools, Enhanced Settings. I'm going to go ahead and make sure everything is just the way I want it. It is. I'm still good to go there. Okay, I'm still active. I'll close that, hit OK. So everything was fine, but I'm going to go ahead and do a download here. Okay, to make sure that Cscape will be ready for the online change that I tried to make here. So even the quote-unquote expert has to get used to new features, right? Okay, so now once this is done, effectively we will have downloaded this new change here, And if we go back into debug mode, okay, we should be able to see what's happening. All right, so if you can kind of notice, all of the variable changes are even numbers. Okay, they're not odd numbers, they're even numbers. Okay, so this increment by 2 is actually happening. If I were to go ahead and go back to incrementing by 1, okay, so I'm getting out of debug mode here, and I'm going to change it to increment by 1. And then now let's go ahead and do a real online change. Hopefully one that won't have trouble. I think I've done it properly now. Okay. Yep, there we go. Let's execute the online change. Online change completed and okay. So when you follow the process properly, guess what? It works the way it's supposed to. Okay, so that's online change. Again, it's quite a bit different than the way it works in Advanced Ladder, and that kind of tripped me up a bit. So we've got to kind of understand the differences there, but we got it going after we followed the appropriate steps. So again, that was online programming. We've also got some other new capabilities that we should mention before we wrap things up here. And that is some of the source code debugging that I briefly mentioned when I was talking about simulation before. And that is things like single stepping, establishing breakpoints in your logic. So executing a logic and then stopping at a certain point. That's especially useful in things like structured text. Establishing trace points so you can follow values as they are solved, or variable values as they are solved multiple times within one scan, for instance. That can be very valuable, as well as a call stack to be able to tell, what's calling what at what level in terms of calls and returns and those sorts of things. So there's all kinds of additional troubleshooting assistance that you can get that's pretty valuable as well. So we'll be covering those in a lot of detail in a future session for sure. So that actually kind of wraps up our session for today. I'm going to bring Casey back in just to make sure we don't have any additional things that I missed. We know what I screwed up on. I screwed up for the world. So I kind of showed everybody that, how not to do online programming the first time. Anything else you think that we need to discuss, or any other questions that came in?
Yeah, I think we just got one more question.
Okay.
And it's from Ross as well. How are things like math errors implemented in online editing mode?
How are things like math errors? Okay, so it's going to react in just the same. Okay, so if there's a problem, okay, I think his question is, let's say I make a programming change and there's a syntax error with that programming change, for instance.
Yeah.
What happens then? Well, the syntax error will be caught before the download actually happens. So there's actually an error check that's going on before the download, even in online programming mode. So that would prevent that from occurring. Now, a feature that we touched on, but we didn't go into great detail on, is the fact that you do have the ability in your logic to handle, for instance, adding some structured text logic to a routine, a special routine that executes every time there is like a divide by 0 error, for instance. So let's say you have not a syntax error, but a scenario where you're doing math and yep, you get a divide by 0 error for a change that you made, whether it was online or not. The controller is going to react the way it normally would react if you're not doing anything with that error handling, and that is it's going to reset. Okay, and you're going to wonder, why did my controller just reset, my program reset? So that's where, if you can take advantage of adding some logic into that routine that handles divide by zeros, for instance, or handles when you have an array whose index is illegal or exceeded the range of that actual variable, then the machine will react better because it won't do a reset, right? So those are some other features we'll need to cover with more detail in the future.
And one more question that just came in, basically for online changes, in order to make a permanent change, do you need to do a full download after? Which I believe the answer is yes, right?
Yeah, I believe that is still true. If it's not, we'll issue a correction next week. But yeah, I believe that's still true, because when you're doing your online change download, it's downloading it to a separate area of memory, and when you say to accept the change, it's swapping locations, right? And you need to be able to tell the OCS, okay, now that's not exactly. Let me correct that. If you go out of online change mode, you don't have to power cycle the controller. If you go out of online change mode, that's what tripped me up in a previous live stream. If you go out of online change mode, that makes it permanent. Yes. So you just have to go out of online change mode. So don't just shut Cscape off without taking the controller out of online change mode, and then your change will be permanent. You won't have to do anything else. I almost messed that up again. Great question, though. I'm glad he asked it. I'm glad he asked it. Okay, so that's it.
I think so.
All right, very good. Well, thanks for joining me and help keeping me straight, Casey, as you always do. Somebody's got to do it for sure. And thank you to Marcy, who's in the background, also making things are going as smoothly as possible, at least. Let's talk a little bit about next week. Next week, we're going to be taking a little bit of a departure from our software reviews to talk about CSCAN networking and how it works. CSCAN is the built-in CAN-based network into every OCS controller. It was invented for high-speed networking on material handling applications. We did a huge project with the U.S. Post Office years ago that caused us to actually invent this protocol. It works beautifully, and we want to tell you all about how it works and how to use it in a practical fashion, and we're going to be covering that next week. So once again, thanks for joining us, and we look forward to seeing you again, virtually, of course, next Tuesday.